Good morning, everyone. Today we're going to take a look at moles and reactions. We're going to see how mole ratios and equations get along together. Propane is burned in many rural homes for heat in the winter. Below is the balance equation for the combustion of propane. Here it is. Propane plus oxygen yields carbon dioxide and water. For each molecule of propane that's burned, there needs to be 5 molecules of oxygen present. Likewise, if there were a dozen molecules of propane, 5 dozen molecules of oxygen would be required. Similarly, for each mole of propane, 5 moles of oxygen are needed. Also, for each mole of propane burned, 3 moles of carbon dioxide and 4 moles of water are produced. The numbers of moles of each substance in a chemical equation are related by the ratio of the coefficients of each substance. How many moles of water are produced when 1.45 moles of propane are combusted? Okay, for this, we use the dimensional analysis that we've talked about before. This is what I'm given, right? We have this much, and here's the question that I'm asked. How many moles of water? Okay, so if I look at my equation, I'm starting with propane over here, and I'm asked about water over here. Okay, so I'm going to start off with my 1.45 moles of propane, 1.45 moles of C3H8, and I'm going to multiply that by my mole ratio. I have 1 mole of C3H8 for every 4 moles of water produced, right? So my 4 moles of water is going to go up there, and my 1 mole of C3H8 goes down there. I plug that in my calculator. 1.45 times 4 divided by 1 equals 5.8 moles of water, right? Moles of water is what I was asked for, moles of water, so I stop there, right? How many molecules of water is this? Well, that's where we'll just take this and do the same kind of thing we did in the last unit. 5.8 moles of water times, right? How many molecules? Here's my question. How many molecules of water? What am I given? This value here, 5.8 moles of water. 5.8 moles times, how many molecules in a mole? 6.02 times 10 to the 23rd molecules of water in 1 mole of water. Okay, moles of water cancels out, and I plug that in my calculator. 5.8 times 6.02 times 10 to the 23rd equals 3.49 times 10 to the 24th. Don't miss this on your calculator. You have to look for that E now to see what the exponent on 10 is going to be. So this many molecules of water. Right? If 2.35 moles of carbon dioxide are produced in a reaction, how many moles of water would be produced? Okay, so again, let's find the 2 things I need, right? If this is produced, this is my given, right? Here's my question, how many moles of water? That's my question. So that's where I want to end up. This is where I'm going to start. 2.35 moles of carbon dioxide times, what's my mole ratio? 4 moles of water, but in this case, we're not looking for C3H8. This is no longer what we want. We want carbon dioxide here. Those 2 will make my ratio. I want moles of water. That's going to be the one on the top. 4 moles of water for every 3 moles of CO2 that's produced. And that's set up so that those moles can cancel out. I plug those in my calculator here. 2.35 times 4 divided by 3. Right? 0.467 moles of water. Right, I messed up because I forgot the 2. Let's try that again. 2.35 times 4 divided by 3 equals, there we go, that's a better number. Alright. Alright. You notice how I had more water produced than I did carbon dioxide, but my answer that I plugged in the first time was way smaller than the amount I started with. That's what I looked at. I said that number doesn't seem right because this is so big and I'm supposed to get more water than carbon dioxide. Okay, so I've fixed that. I fixed my error. 2.35 times 4 divided by 3 is 3.13 moles of water, which makes more sense. I should have more water produced than carbon dioxide because I get 4 waters while I only get 3 CO2s. All right. Why is this statement false? If 10 grams of propane burn, you need 50 grams of oxygen. Chemical equations are mole ratios, not mass ratios. Okay, let's see. If 27.3 moles of carbon dioxide are produced, right? So this is the thing I'm given during the combustion of a certain amount of propane. How many moles of propane were combusted? All right, so this is my question. This is my given. I always start with the given. 27.3 moles of CO2 times, let's see, how many moles of propane? So I have 1 mole of propane for every 3 moles of carbon dioxide. So 1 mole of C3H8 for every 3 moles of carbon dioxide. Right? 1 mole from here, 3 moles from there, because I have 3. Right? So, how do I do that? 27.3 moles of CO2, right? Moles of CO2 cancels, that's lined up right. So I multiply it by 1 divided by 3, that's what this fraction line means, divided by, times 1 divided by 3, right? 9.1 moles of C3H8. How many grams of propane was that? Well, I've got to go back. Was that? I have that much propane, so I got to put that in here. 9.1 moles of C3H8 times, I need a ratio here, right? Moles here, I'm going to need 1 mole C3H8 down there. For this, I have to go to my periodic table. Okay, and carbon is 12.01 and hydrogen is 1.008. So 1.008 times 8 plus 12.01 times 3, right? That equals 44.09 grams of C3H8. Alright, so now I can plug this in my calculator. 9.1, I don't know why I put a colon here, let's get rid of that. 9.1 moles. 9.1 times 44.09 divided by 1 equals 401.2 grams C3H8. Okay, so that's the first page here. Let's take a look, because we're just going to continue on with some of these problems, because this is the process that we need to learn in this one. Okay. All right. If you have 410 grams of propane and want to know how many grams of oxygen are required to burn it, you can follow these steps. Number one, find the number of moles of propane you have and convert the grams to moles, right? So 410 grams of C3H8 times 1 mole of C3H8, and from the previous page here, I know that the molar mass of propane is 44.09 grams, right? In this case, I have grams and I want moles, right? So that's why I'm doing this. Grams cancels out here and I get moles, okay? So let's do that. 410 times 1 divided by 44.09, right? 9.299 moles of C3H8, okay? The moles of propane are related to the moles of oxygen by the ratio of coefficients in the balanced chemical equation. Find the number of moles of oxygen you need given the moles of propane from part A. So here I have 9.299 moles of C3H8, and now I need to use my balanced chemical equation, which if I look back here, there's 1 mole of propane for 5 moles of oxygen, right? So in this case, I have 5 moles of oxygen for every 1 mole C3H8. Okay? Then find the grams of oxygen from the moles of oxygen. Wait, sorry, let me finish this. Getting ahead of myself. So 9.299 times 5 divided by 1 is 46.496 moles of oxygen. Okay, now find the grams of oxygen from the moles of oxygen. Okay, so I'm going to start with this value up here, 46.496 moles of oxygen times, well, how much does 1 mole of oxygen weigh? Right, well, let's see, it's 16 times 2 is 32. 32 grams of oxygen for every mole of oxygen, right? So again, my moles cancel out here, right? 46.496 times 32 divided by 1, right? 1,488 grams of oxygen. Okay, now I'm going to verify that this statement is correct. If 315 grams of propane combusts, then approximately 515 grams of water are produced. Okay? Now, we're going to do the same thing, but notice that instead of stopping at each step along the way, I'm just taking the answer to this one, right, and multiplying by another thing, and then taking the answer to that and multiplying by another thing. I can put all of these together and line them up, and if I line them up so that my units cancel top to bottom, left to right through all of this, I'll get that same answer, but I only have to plug it into my calculator once. So I'm going to start here with 315 grams of C3H8, right? I want to convert my grams to moles first, right? Molar mass is 44.09 grams in 1 mole C3H8, right? Now, I want water. I know from my balanced equation here that there are 4 moles of water for every 1 mole of propane. Okay, so here I'm going to have 4 moles of water for my 1 mole of C3H8, my propane, from my balanced chemical equation. Then I'm going to use the molar mass of water. 1 mole of water, right? Let's see, that's 1.008 times 2 plus 16, right? I get 18.02 grams of water. Okay, now let me double check before I plug it in the calculator. I have grams of propane and I have grams. I can put this here if I want, C3H8, right? Grams of propane cancels top to bottom. Okay, mole of C3H8, that cancels out next. Moles of water, that cancels out next. I have grams of water, right? I'm looking for grams of water. So the only unit I have left is grams of water. So I should be able to plug all this in my calculator and get that answer. 315 times 1 divided by 44.09 times 4 divided by 1 times 18.02 equals 515 grams of water. And so I have verified it, 515 grams, that's the answer I get. And that's how you do it. Okay, so let's do one more. We have a new equation. I'm going to start with, okay, 425 grams. This is my given. How many grams of hydrogen and nitrogen can be produced? So I have problem 1 and problem 2. Okay, so I'm going to have 2 things I have to find here. Right? Start off with 425 grams NH3 times 1 mole of NH3 weighs how much that weighs. So I look on my periodic table, right? Nitrogen is 14.01. So 14.01 plus 1.008 times 3, right? 17.034 grams of ammonia times, let's do hydrogen first, 3 moles of H2, that's what I have there, for every 2 moles of NH3, right? And I want grams of this, so I got to convert that. 1.008 times 2. There's 2.016 grams of hydrogen for every mole of hydrogen, right? So grams of ammonia, moles of ammonia, moles of ammonia, moles of hydrogen, moles of hydrogen. Everything is lined up in a pattern. I have grams of hydrogen left, so I must be able to plug it in my calculator now. 425 times 1 divided by 17.034 times 3 divided by 2 times 2.016 divided by 1. Double check my numbers. 425, 1, 17, 3 over 2 times 2 divided by 1 equals 75.5 grams of hydrogen. And we'll do a similar problem for the nitrogen here. So I'm starting again off with my same given, 425 grams of NH3, right? This first step will be the same. 1 mole NH3 weighs 17.034 grams times, I have a different ratio here, 1 mole of N2 for every 2 moles of NH3 times, I need nitrogen. Nitrogen again is 14.01. 14.01 times 2, 28.02 grams of N2 for every 1 mole of N2, right? It's lined up, grams of ammonia, mole of ammonia, mole of ammonia, mole of N2, mole of N2, grams of N2. That's what I'm looking for, grams of N2. So let's plug it in. 425 divided by 17.03 times 1 divided by 2 times 28.02 divided by 1. Double check those. Looks good. I dropped this 4 here. Let me go back and put that in. All right, enter. 349.6 grams of N2. And that's how you do these problems.